Indonesia is an archipelago country. The earthquake and tsunami are part of the threat of the natural disasters, especially those living along the coast, because it requires a housing model that is resilient to these disasters. This house must also have its own energy source, especially from renewable energy sources, which Indonesia is rich in solar radiation. Used containers are also increasing but unutilized. With this background, this concept is developed to answer the existing problems and open opportunities to be improved. One of the innovations Track has made is a dual powerhouse. This system is a prototype to promote DC-based homes. We are trying to build a house that uses a hybrid system having both AC and DC systems. With the development trend of renewable energy, especially energy from the sun, Track sees the potential for the uses of DC-based electricity to grow fast in the future. In our effort to develop DC-based electricity from renewable energy sources and keep up with the momentum of international movements as well as technological developments related to renewable energy, such as electric vehicles, we are trying to make a robust DC system for the household for industrial use. In Universitas Indonesia, we have made a pilot project using container waste as a property that can provide its energy from a local renewable energy source. We use PVs or clean energy with low carbon emissions such as fuel cell to energize this house. The excess energy from the photovoltaic will be stored in a battery, and if there are lack of energy, the system will automatically use a fuel cell. In designing this project, we have benchmarks which are 6R. In this context, recycling means that the model can be replicated into a new stuff in a cyclic process of circular economy, and the container waste turned into a property. In this system, reuse means that the container can be used again for a different purpose. For example, the container may be used to transport humans after previously being used to transport objects. Reduce means that the model can be produce its energy from a clean energy source to reduce carbon emissions. Renewable means that the model can produce energy from a surrounding renewable energy source. Reliable means that if there are any trouble such as generation failure and short circuits, the system can still be independent because of distributed generation electricity, which supports the decentralization of electricity. Resilience means that if there are any disasters happen, this model can still survive. These points are important considering that Indonesia is located in a geographic area of the Pacific Ring of Fire, which increases the chance of flooding and earthquakes. The way a dual powerhouse works is solar energy is converted into DC electricity using photovoltaic with a specification of 3 kW peak. The electrical energy generated will be stored by a battery 19.2 kWh and a fuel cell 5 kW. In addition to being stored, the DC electrical energy will be converted into AC with a 5 kW inverter for AC loads and a 48 volt to 230 volt DC voltage with a 2.5 kW DC on for DC loads. The lack of energy will be recovered from a grid's 220 volt alternating current. The flow of electrical energy stored and flowing to the loads will be regulated by a 48 volt and 40 amperes charge controllers. This house has electrical appliances in general, such as lights, fans, TV, bedroom, heater, and air conditioning. The need for electrical energy for electrical equipment is the basis for designing the energy system in this house. The initial stage of the design is to calculate the accumulation of electrical loads in this house. This house load profile is around 8 kWh per day with a peak load of 2.2 kW. The peak load value is the basis for determining the inverter specification, which is 5 kW. Solar radiation around this area is 4.76 kilowatt-hour per meter quadrat per day, with ideal energy of 14.28 kilowatt-hour per day. We use a derivative factor of 0.8 from the initial calculation to find real output energy. The radiance becomes 11.424 kilowatt-hour per day with the optimum time of light intensity in 1 day based on GHI and geographic location is 4 hours. So the specification of the solar PV is 3 kilowatt peak. For battery specification, it is 19.2 kilowatt hour with a depth of discharge of 80%, which is 15.36 kilowatt hour. The specifications can back up the loads for 2 days without a supply other than the battery. The 5 kilowatt fuel cell serves to back up the battery and the 2.5 kilowatt DC on for the DC loads. We hope that the appearance of the track dual Powerhouse can accelerate the development of renewable energy, especially energy decentralization, and even each house can independently produce electrical energy. In addition to developing eco and green building materials, we are also trying to promote a green energy community with various activities such as the International Tropical Renewable Energy, green energy education, product exhibition, and our seminar series.